right, now we're going to just be solving some rational inequalities. We're going to use a page that we did before. It says 8-6 skills practice at the top, and we used it to solve rational equations, but now we're actually going to solve the inequalities as well. It's down at the bottom of the page, numbers 19 through 24, that we're going to work on. I'm kind of going to jump around and do them out of order, and I'm going to write them down because they're very small and hard to see. Plus, they use letters other than X, and because we're going to use our calculator to solve these, I'm just going to replace everything with X. So what we're going to do first is let's look at number 23. I think that's a good place to start. Number 23, they have M's, but I'm going to use X's. It's 1 over 2x minus 3 over x is less than negative 5 halves. So this is the problem we're going to be looking at. Now, it's an inequality because of this less than sign. Rational inequalities present a problem for us when we solve them by hand because they present some false answers. And it's going to be easier for us to just use our calculator to solve these. So what I want you to do is whatever's on the left-hand side, I want you to plug into y1. Use your fraction bar to do this. So I'm going to plug in 1 over 2x minus, and I'm using my fraction bar again, 3 over x. So that's the left-hand side. And then I'm going to come down and I'm going to put the right-hand side in y2. Now, because I'm plugging in multiple lines or graphs, I'm going to arrow back, and I'm going to make this second line bold so that when my calculator graphs it, I know exactly which one's which. Okay, so now it is bolded. Now I'm going to hit graph. There's my first set of lines. Well, my calculator zoomed a little weird. I'm going to zoom 6 and go back to my standard window. Okay, there's my original left-hand side of the equation, and there's my right-hand side, that bold line. Now, my sign here says less than. And the less than number, so what I want is for the left-hand graph to be less than the right-hand graph. Or I want my non-bolded graph to be less than the bold graph. So if I look here, I'm looking for everything below this bold line. So I'm just looking for this tiny little segment of graph. Well, remember, when I solve these, I'm trying to figure out what x is. And it is going to be an interval. So whenever we talk about this, we're looking for the x values. Well, if I look at this little piece of graph, this x value down here is approaching 0. It's trying as hard as it can to get to 0. Now, it's never going to touch 0 because of that asymptote there. But it's going to go from 0 to right here, wherever these two graphs touch. I'm not sure where that is, so I'm going to do a second trace and intersect to identify that place. Now, where's my cursor? Oh, there it is. I'm going to hit enter. It jumps to the second curve. Hit enter again and enter. Oh, and the intersection's actually right there at 1. So this little piece of graph goes from 0 to 1. That is the only place where the left-hand side is less than the right-hand side. So that is your answer. Now, this is an interval notation. I could also write it as 0 is less than x, which is less than 1. This would be algebraic notation. Or you could write it on a number line. I could write it as 0 to 1, open circles, shaded in between. Now, the reason these are open circles is because the 0 is an asymptote, so it's never going to touch that. And the 1, this sign says is less than. And right there at 1, the two things are equal. So it doesn't say less than or equal to, so it's not a bracket. It's not a bracket or a solid dot or a less than or equal to sign. It's actually open this time. All right, so let's try another one. So really, we're just plugging in the calculator and interpreting the graph. So let's try one that might look a little bit different. Let's do number 24. Number 24 is 1 over 2x is less than 2 over x minus 1. So I'm going to do the same thing. I'm going to plug this into my calculator. I'm going to plug the left-hand side into the y1. And in y2, I'm going to plug the right-hand side. I'm just over-typing what was in here because I already had some fraction bars, so made it a little easier. Check myself and just make sure it's right. I have 1 over 2x, that's the left-hand side of number 24, and 2x minus 1. Again, I'm looking for where the left hand of the graph is greater than the right hand, or the non-bold, I'm sorry, is less than. The non-bold is less than the bold. So I hit graph. There's the non-bold, and there's the bold. Now I'm looking for where it's less than, so that means underneath. I'm looking for where the non-bold is less than the bold. Looking for where the non-bold is underneath the bold. Well, over here on the left-hand side, it's not. It's above it. On the right-hand side, it looks like it might go underneath. I'm going to zoom in, hit zoom 2. Now it hasn't zoomed in yet. If you can tell, there's a flashing cursor right in the center. It's asking me where I want to center my zoom. I'm actually going to arrow it over a little bit and center over here where it looks like my non-bold line drops below. There's my non-bold line. There it is. So I'm looking for where my non-bold line is below my bold line. Well, you can see the non-bold is below the bold line till here. So over here it's approaching 0. Remember, we are looking for x values here. So it's going to 0. It's getting as close as it can to 0 because of that asymptote. And it's going to here. I'm not sure where that is, so I'm going to do a trace intersect. And it tells me my intersection is at 1.5. So this little piece of graph, the non-bolded, from 0 to 1.5 is below the bolded graph, or is less than. Again, this time it's just a less than sign, so it's just a less than sign, so there's no brackets. I could write it this way in interval notation. I could write it in algebraic notation. X is between 0 and 1.5. Or I could write it on number line notation, 0, 1.5. These are open dots again, and it goes between those two places. All right, let's look at another one. Let's look at one where 1 is greater than. Let's look at number 20. On number 20, they have 3 over x minus 4 over 3x is greater than 0. So I'm going to plug that into my calculator. Plugging the left-hand side into y1 and the right-hand side into y2. I'm going to use my fraction bar. So I'm going 3 over x minus 4 over 3x. And I want that greater than 0. 0 is just the axis. It's just the x-axis, so I really don't have to put that in, but I'm going to just for the sake of continuity. I'm going to arrow back and make this bold and hit graph. Oh, I'm still zoomed from my last equation, so I'm going to zoom back in to standard. So zoom 6 will take me back to my standard window. All right, this time I am looking for where this piece of graph is greater than 0. Greater than 0 would be anything above the bold line. So from here all the way out. So in this case, I am going from, remember, we're talking x values here. This x value is approaching 0. And this x value is going all the way to infinity. So this time my answer is 0 to infinity. That's an interval notation. If I was going to write this in algebraic notation, I would write x is greater than 0, because that would indicate it's going all the way to infinity. Or if I'm doing a number line, I would put 0, open dot, and shade. And shade the arrowhead also, because it's going all the way to infinity. So that's how you solve rational expressions, inequalities, I'm sorry. That's how you find rational inequalities using your calculator.